In this section, we're going to be solving equations that have rational expressions inside of them. Okay, let's look at example 1. Before we can do much of anything, I really need to know what the bottom of these fractions are, and one of them isn't factored, and so it's going to be in our best interest to first thing get that guy factored. So let's take a look at this. It's a lead coefficient of 1, so we can go straight to the factors. It's a minus in the back, so -6 means I'm going to have different signs. And I want something that multiplies to 6, but would give me a -5 in the middle. So we're going to need -6 and a +1. Once we're here, one thing you can do is stop and think about what x cannot be, because that can cause problems sometimes. Remember, the bottom of a fraction can't be 0. So in this case, x plus 1 cannot be 0, and x minus 6 cannot be 0. So x cannot be -1, and x cannot be 6. At the end of the problem, if we get -1 or 6 for our answers, we're going to have to get rid of them. They're not legit answers. Okay, next thing, we need to decide what we're going to do to fix this, because I hate having all these fractions. We can quickly get rid of the fractions by multiplying everything by the least common denominator. The least common denominator for this one would include x plus 1 and x minus 6. The goal of this is to have the bottoms all cancel out. So whatever's on the bottom needs to be in your least common denominator. Now what we're going to do is we're going to multiply everybody by the least common denominator, technically the least common denominator over 1, if that helps. That's legal because we're taking a balanced equation and blowing up everybody by the same factor. So you can think about if you have a balanced scale and you added 10 pounds to both sides, it's still a balanced scale. So we're going to blow everybody up by that least common denominator by multiplying everybody by the least common denominator. So we're going to take the first piece of our equation, 4 over x plus 1, and multiply it by that least common denominator, which was x plus 1 and x minus 6. And you can put over 1 if that helps. And then we're going to do the next bit. The next piece of this, I'm going to go ahead and leave it factored. And it is going to get multiplied by the least common denominator. And then we've got one more piece. It is also getting multiplied by the least common denominator. Everybody gets multiplied by the least common denominator. And visually for me, it helps if I draw a box around each of these multiplication problems just to kind of keep track of what I'm doing, because it can get kind of busy. If we've done this correctly, each of these boxes will reduce and we will get rid of the fractions. So let's look at the first one. In the first box, I have a common factor of x plus 1 I could get rid of. That's going to leave me with a 4 and an x minus 6, and nothing but 1's on the bottom, so they're gone. Don't need them. Let's look at the next one. Here, lots of things are going to cancel. And I'm going to get a bunch of 1's times a bunch of 1's, which is still just 1. In the last box, x minus 6 will cancel. And I got a bunch of 1's times x plus 1. Well, 1 times x plus 1 is just x plus 1. We have taken that big nasty thing and turned it into a much nicer equation without any fractions. So now you're going to tap into your old algebra skills, and we're going to solve this equation. I'm going to distribute my 4. And you'll notice on this one I don't have any x squareds. This isn't a quadratic. This is a linear, meaning we can put all the x's on one side and all the numbers on the other. First things first, I've got a couple like terms here. I'm going to go ahead and put those together. And then we can start moving things around. To get things on the same side, I think I'm going to minus the x to get my x's over here. And then I will add the 23 to get my numbers over here. So these are going to cancel, and these are going to cancel. So on the left side, I've got 4x minus x, or 3x. And over here, I've got 23 plus 1, or 24. Last but not least, to get x by itself, we're going to divide by 3. And I've got x equals 24 divided by 3, or 8. Before we call it done, though, check and make sure. Was he an okay answer? Well, he's not -1, and he's not 6. So, yep, he's good to go. Our answer would be 8. If you had extra time on a test and wanted to check this, you could. You would put 8 back in everywhere that you see an x, and simplify all of this stuff together and simplify this, and you would get the same thing on both sides. Let's try one more of these. I don't have to worry about the bottoms here. They're all factored. So we're going to go ahead and start probably by saying, what can x not be? Well, the bottom of a fraction cannot be 0. So x cannot be 0, and x cannot be 1. So if we get 0 or 1, we got a problem. Next, we're going to decide what is that least common denominator. What do we have to multiply everybody by so that all of the bottoms will cancel? Well, I've got a GCF x, and I have a factor of x minus 1. So we're going to need to multiply everybody by x times x minus 1. Let's take that first fraction, 5 over x, and we're going to multiply him by x and x minus 1, technically over 1. Again, I'm going to put a box around this just to kind of keep my thoughts organized a bit better. The second one, also going to get multiplied by x and x minus 1. Again, I'm putting a box around to make me feel better about this. The last one, times x and x minus 1, and we'll put a box around him. Okay, if we've done this correctly, we should be able to cancel things and get rid of all of the fractions. So in the first one, I could cancel this x with this x. That's going to leave me with 5 and x minus 1, and just 1's on the bottom, so that's good. The second one, I could cancel x minus 1 and x minus 1. So I'm going to have 2 times x, which is 2x. And in the third box here, I can cancel x minus 1 with x minus 1. And I'm going to have 2x times an x. All right, let's get rid of these parentheses. Distribute my 5, so I'll have 5x minus 5 plus 2x. Now let's think about this one over here. 2x times x. Well, x times x is x squared, so this is going to be 2x squared. Okay, when we have an x squared, that means this is going to be one of those problems that we're going to have to set it equal to 0, factor, set each of the pieces equal to 0. So in order to factor, I want this x squared guy to be positive, so I'm not going to move him. I'm going to bring everybody to him. Before I do that, I do see I've got a couple x's I could put together. That might help us a little bit. So let's put those together, and then we'll start moving things around. I want to leave this guy alone because he's positive, and that's going to help me factor. But I am going to move the 5 to the other side. So I'm going to add the 5. I also need to minus the 7x so that I can get 0 on this side, because this is going to cancel, because negative 5 plus 5 is 0. 7 minus 7 is 0. So that gave me 0 on this side. And then in the correct order over here to factor, I'm going to have that. Okay, good news, bad news. We're getting closer. The bad news, though, is this is a lead coefficient of 2, so I may want to come out to the side here and use AC method to factor this. So I'm going to come factor this. 2x squared minus 7x plus 5. Let's just get him factored real quick. So AC method, 2 times the positive 5 is positive 10. If it's going to be positive, they're both positive or both negative. To get a negative 7, though, they're going to both be negative. Multiplying to 10, that's got to be 2 and 5. So we're going to break up that negative 7x into negative 2x and negative 5x. Then we can do our grouping. Pull out a 2x, which would leave me with x minus 1. Here I can pull a 5, but I want this x to be positive, and right now if I pulled a 5 from here, I would have a negative x, and we don't want that. So I'm going to pull a negative 5. That's going to change this to positive x, and it's going to change this to negative 1. That's good, they match. We're in business. Okay, finally got him factored, so now we can come back over here and put in our factors. Once we have it factored, we are going to set each of those equal to 0. So we've got 2x minus 5 equals 0 and x minus 1 equals 0. To get x by itself, I'm going to add the 5 and then divide by my 2. And so I got 5 over 2. Over here, I'm just going to add the 1. And I got 1. So my answers are 5 over 2 and 1. Hold up, though. Look back up here. X cannot be 0 and x cannot be 1. So this poor little 1 is gone. He is not a valid answer. This 5 over 2 is the only answer that we get to count. So when you think you're done, remember you got to double check. Sometimes you're going to get answers that are part of those excluded answers from the beginning. If I tried to put 1 back in, I would get a 0 on the bottom of a fraction, and we cannot have that. That's a big no.